Okay, we are doing section 1, what is weather, part 2. We're going to call this all about the clouds. Where's my thing? There it is. Alright, ready? Here we go. What is weather? Ooh, whoa. Oh my goodness. What has happened there? Alright, clouds. Forming clouds. Why are there clouds in the sky? Clouds form as warm air is forced upward, expands, and cools. Figure 5 shows several ways that warm, moist air forms clouds. As the air cools, the amount of water vapor needed for saturation decreases. Back. Right here. And the relative humidity increases. When the relative humidity reaches 100%, the air is saturated. Water vapor soon begins to condense in tiny droplets around small particles such as dust and salt. These droplets of water are so small that they remain suspended in the air. Billions of these droplets form a cloud. Now, before we see what we're going to write down, I want to discuss, because this has a lot of information that you know already. Okay? This part here, as the air cools, water vapor needed for saturation decreases. This is all about dew point. So if you remember your table, your graph you have, as we get colder, dew water condenses easier. Okay, it's not moving around as much. Then, when the relative humidity is 100%, the air is saturated. That is the top of the bar when we're looking at our graphs. Now, we did this in the bottles. When we squeezed the bottle after putting the match in it, the smoke from the match was our dust and salt, and the water vapor condensed around the smoke from the match. Alright, so we are in section Roman numeral 3. This is our third blue heading in our textbook, forming clouds. Okay, this is a process right here. Alright, the warm air is forced upward, it expands, it cools, the dew point is reached, that's saturation, water vapor condenses around small particles. In your Kaggle, you will put all 5 of these, one after another, and billions of droplets make a cloud. Okay, this is fun. Classifying clouds. Clouds are classified mainly by shape and height. Some clouds extend high into the sky and others are low and flat. Some dense clouds bring rain or snow, while thin, wispy clouds appear on mostly sunny days. The shape and height of clouds vary with the temperature, pressure, and the amount of water vapor in the atmosphere. Okay, so underneath that you're putting Roman numeral 4, classifying clouds. Clouds are classified by the shape and the height, and the type of cloud depends on temperature, pressure, and the amount of water vapor. We're seeing a theme here between temperature and pressure, aren't we? Alright, so here's our graphic. Okay, we have these tall, high clouds. Rays from the sun heat the ground and the air next to that. We know this already. This is radiation and convection. The warm air rises and cools. If the air is moist, some water vapor condenses and forms clouds. Okay, the air is moist. We call that humid air. Alright, so it heats the damper, evaporates the water into the sky. Here's the second one. As moist air moves over mountains, it is lifted and it cools. Okay, we know that cold air makes clouds. Clouds formed in this way can cover mountains for long periods of time. Okay, and then we have a front. When cool air meets warm, moist air, the warm air is lifted and it cools. Okay, because cool air is denser and it's more tightly packed. Alright, what happens to the water vapor when the dew point is reached? That's a good question. Alright, we're on to page 41. Okay. Now we're going to break this down. The 3 main cloud types are stratus, cumulus, and cirrus. Stratus clouds form in layers or smooth, even sheets in the sky. Stratus clouds usually form at low altitudes and may be associated with fair weather or rain or snow. When air is cooled to its dew point near the ground, it forms a stratus cloud called fog, as shown in Figure 6. Alright, I have a problem with this because you're inclined to say stratus clouds usually form at low altitudes and may be associated with fair weather or rain or snow. My question to you is, what other kind of weather is there? But you will see that fair weather, which is nice weather, can be, we can have almost any type of cloud. Okay, and recognize that fog is a stratus cloud. Okay, so shape is our first Roman numeral. It goes under Roman numeral 3, and our first shape is stratus. Stratus clouds are layers. They look like sheets in the sky. They occur at low altitudes. They signify rain, snow, or fair weather. And when a stratus cloud cools to its dew point near ground, it is fog. All right, the next one, we're going to do this next paragraph. Cumulus clouds are masses of puffy white clouds, often with flat bases. They sometimes tower to great heights, then can be associated with fair weather or thunderstorms. So nice weather or not. All right, so let's add that. So you've got B, cumulus clouds. They are puffy white clouds. They can tower to great heights, and they signify fair weather or thunderstorms. This should be a Roman numeral 3. I'm so sorry. Uh-oh. Whoops. Close your eyes, close your eyes, close your eyes. Don't look. All right. Cirrus clouds appear fibrous or curly. They are high, thin, white, feathery clouds made of ice crystals. Cirrus clouds are associated with fair weather, but they can indicate approaching storms. So fibrous, if you think about a cotton ball pulled apart, that's fibrous. All right, let's go back to where we were. All right, so cirrus clouds are fibrous, curly, thin, feathery. That's how we describe them. They're very high, they're made of ice crystals, and they indicate fair weather or an approaching storm. What do you think would be behind cirrus clouds if it's a approaching storm? Do you think cumulus clouds might be there? Maybe. Let's see where we go next. Nope. Okay, so here's fog. This is the Golden Gate Bridge in San Francisco. If you look, why do you think fog is found in San Francisco Bay? If you find San Francisco on a map, I want you to tell me what surrounds it. San Francisco. Nope, I'm not supposed to do it. Okay. Alright, and this is a cirrus cloud, and these are the ice crystals. Okay? Funny that that ice is high up in the sky. Alright, so height, I believe, is next. It keeps wanting to come. Oh boy. Alright. Okay, height. Some prefixes of cloud names describe the height of the cloud base. It's my dog. The prefix cirro describes high clouds, alto is middle level, and strato refers to clouds at low elevations. Some clouds' names combine the altitude prefix with the term stratus or cumulus. Cirrostratus clouds are high clouds, like those in Figure 7. Usually cirrostratus clouds indicate fair weather, but they also can signal an approaching storm. Altostratus form at middle levels. If the clouds are not too thick, sunlight can filter through them. Alright, so what do you think we're going to write down? I want you to pause the video, and I want you to tell somebody who's there what you think you're going to write down. Do you see words that are italics? Yeah, those are pretty important. Let's go find out. Or not. Okay, height. B, height. There you go. I hope you knew that. The prefix can tell the height. So the prefix CIRRO is a high cloud. Alto is a middle level cloud, and strato is a low cloud. Okay, the prefix can be combined with stratus or cumulus. So a cirrostratus cloud is a high cloud that is a layer. What would a stratocumulus cloud be? Oh, dog, stop it. All right. We've done that. We've done that. Here we go. All right, we are on page 42. All right, then we have rain or snow producing clouds. Clouds associated with rain or snow often have the word nimbus attached to them. The term nimbus is Latin for dark rain cloud, and this is a good description because the water content of these clouds is so high that little sunlight can pass through them. When a cumulus cloud grows into a thunderstorm, it is called a cumulonimbus cloud. These clouds can tower to nearly 18 kilometers high. Nimbostratus clouds are layered clouds that can bring long, steady rain or snowfall. How high is the troposphere, I ask you? Yes. Okie doke. Capital letter C, rain or snow producing clouds. If you're on a new page, make sure you are writing on the right hand side. Nimbus, dark rain cloud. B, so much water, no sun shines through. C, cumulonimbus is a thunderstorm. It could be as high as 18 kilometers high. And nimbostratus might mean days of rain. Okay? Let's go look at a little precipitation. Water falling from clouds is called precipitation. Precipitation occurs when cloud droplets combine and grow large enough to fall to earth. The cloud droplets form around small particles such as salt and dust. These particles are so small that a puff of smoke can contain millions of them. Did you not have a puff of smoke in your bottle today? Did you know there were millions of particles? Wow. All right, Roman numeral 5. Precipitation. A, water falling from clouds, aka rain, but not always. B, water vapor forms around teeny particles. C, droplets combine, get heavy, and they fall to earth and land on your noggin. All right. And yes, this is crooked, and I'm sorry. You might have noticed the droplets are not all the same size. The size of raindrops depends on several factors. One factor is the strength of updrafts in a cloud. Strong updrafts can keep drops suspended in the air where they can combine with other drops and grow larger. The rate of evaporation as a drop falls to earth also can affect its size. If the air is dry, the size of raindrops can be reduced or they can completely evaporate before reaching the ground. Okay, an updraft. If you think about a cloud, you think it's still. But no, there's always air moving inside a cloud. So an updraft is pushing things around in the cloud from the bottom up. Size factors. A, updrafts in a cloud may keep drops to grow bigger. And B, the level of evaporation in the atmosphere can make drops smaller. Alright, and then the air temperature determines whether water forms rain, snow, sleet, or hail. The 4 main types of precipitation. That's my dog. Figure 8 shows these different types of precipitation. Drops of water falling in temperatures above freezing fall as rain. Snow forms when the air temperature is so cold that water vapor changes directly to a solid. Yay! Sleet forms when raindrops pass through a layer of freezing air near Earth's surface, forming ice pellets. So the rain comes down, but then all of a sudden it goes through cold air that turns it into ice. Okay, there's a difference between sleet and hail, and you're about to learn the difference. That is my dog trying to dig under the bed. All right, type. The factor to makes the type is air temperature. Rain, temperature is above freezing. Snow, temperatures low, the droplets turn directly to a solid. Sleet, droplets pass through a layer of freezing air. Recognize that snow is different from what comes down as sleet. All right, so water vapor in air collects on particles to form water droplets or ice crystals. The type of precipitation depends on the temperature of the air. So when the air is warm, water vapor forms raindrops that fall as rain. Bloop, 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 bloop. Happy flash. Uh-oh. Okay. Then we have air is cold, water vapor forms snowflakes. Okay, so the droplets come down solid, bland, snowflakes. Yay! Ooh, pretty. What do you know about snowflakes? Something special. All right. We're on the last page, page 43. Tired yet? Hail. Oh. Hail is precipitation in the form of lumps of ice. Hail forms in a cumulonimbus cloud of a thunderstorm when water freezes in layers around a small nucleus of ice. Hailstones grow larger as they're tossed up and down by rising and falling air. Most hailstones are smaller than 2.5 centimeters but can grow larger than a softball. Of all forms of precipitation, hail produces the most damage immediately, especially if winds blow during a hailstorm. Falling hailstones can break windows and destroy crops. All right, and this is a little summary paragraph. We'll go bloop bloop through that. If you understand the role of water vapor in the atmosphere, you can begin to understand weather. The relative humidity of the air helps determine whether a location will have a dry day or experience some form of precipitation. The temperature of the atmosphere determines the form of precipitation. Studying clouds can add to your ability to forecast weather. Yep. Alright, so capital letter C. Hail. A. Lumps of ice in a cumulonimbus. B. Updrafts. Toss the ice around in the cloud. C. Vapor in the cloud attaches to the ice chunk. So it's like making a snowball or the base of a snowman. The more you roll it, the more things attach to it. Okay, it can be from small, 2.5 centimeters, to the size of a softball. E. Hail plus high winds equals lots of damage. All right. Here's our picture of hail and how it works. Okay? Well, no, this is sleet. When the air near the ground is cold, sleet, which is made of tiny, small ice pellets, falls. Okay, so it's rain, 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 and then a cold layer makes sleet. This is what we get a lot. Now we have something else that's called freezing rain, and that is different from sleet. I need you to figure out what freezing rain is. All right, and hailstones, okay, so we have the ice crystal, and it rolls around in the cloud, gathering moisture and freezing until it comes plunk down. Okay, so it can be warm when it hails, but it's a cumulonimbus of cold air. Okay, super duper. So, you did well. It's all done, and I will see you tomorrow. I think we can make hail. I need to see. Bye.